one of the things I like about science, I think I mentioned this a long time ago, is it builds on itself. So the cool thing is we don't have to, have you ever heard the phrase, don't reinvent the wheel? Because somebody already did that, so take off from there. So, I mean, there's just like a body of knowledge that's good and bad. It makes it tough for science teachers these days because so much is known about so many different types, so many different areas of science that we really can't be an expert in it all. But the knowledge is pretty deep out there. So, you know, if you're...
And it's growing.
Knowledge off, like in science,
Yeah, it is growing.
So off science, you're kind of like taking something else that somebody else had did or something, and then you just keep.
Yeah, that's how I picture science. Yeah, they take something that's already been done, something that's known, and something that interests a person. I think, you know, hopefully everybody's going to end up in a job that interests them, and so I think scientists are kind of like that, and they just So it's very, very narrow these days. In the days of like Aristotle and Newton, it wasn't so narrow probably, but.
My mom showed me this article that was like everyday science changes, and it was like interesting because it said something that could have been true, let's say 100,000 years ago, is completely true now. Like it's like one thing will almost never stay the same. Like if that makes sense.
Yeah.
Like something that they may not have like known any information on. Now they're like, oh my gosh, yeah, if you throw like this ball into a black hole, like you know what I mean?
And
Or like
they're building
that,
on it.
like they knew the answer to like completely evolved and like changed, and now they're like, but
Yeah, I agree. It's interesting.
Weird.
It is. So speaking of, these last few slides kind of talk about, you're like, really, a black hole? And again, it goes to how do we, the two things we know, the reason we can identify an object as being a black hole for these star ones, the type 2 supernova blowing up star, is one is the density of, well, that's any black hole, because I'll go over here, you know, if I go over here to this object and I go, you know, okay, I have crammed a certain amount of mass into a volume such that neutron degeneracy cannot support it. Okay, over here, neutron star. Neutrons are like, okay, I'm neutron soup, but okay. Okay, over here, okay, nope, black hole. Then the other thing is, so this actually talks about that. And in order to understand the mass of an object, and we're going to do this for our galaxy too, we look at how it influences the orbit of stuff around it. So stuff we can see is being influenced by this. And so we can gauge this mass. And so we can get to its volume, and we know its mass, so we can get to its density. The other thing, does this kind of look like, remember when we talked about the binary stars, the bloated red giant, either a companion white dwarf we talked about, you get novas and the supernova 1As, or the neutron stars, remember we talked about, neutron star over there, accretion disk. We said you can get gamma ray bursts. Okay, well here we go again. Except that is not a neutron star, that is a black hole. And instead of getting X-ray bursts, I guess I must have said X-ray bursts with neutron stars, because gamma rays are more energetic. We can get these kind of flashing, okay, from the accretion disk. So one of the stars in the Northern Cross is actually Deneb, and Deneb is right here. Okay, so there's the Northern Cross, and this star right here actually is a pair of objects, and one of them's a black hole. No kidding, our go-to scope, the school's go-to scope, you know, you say, I want to go to this, blah, blah, blah. You can actually go to a black hole. Really? I know. I can't tell it's a black hole. So, the caption for the previous slide, that said something about X-ray bursts. X-ray binaries, all right. Okay, so that's what I thought. Gamma ray bursts are actually then associated with black holes being dumped on by a companion. Okay, gamma ray bursts getting dumped on by a companion. Oh, wait a minute. No. Gamma ray bursts are from, this says, they're not getting dumped on Gamma ray bursts are from the formation of a black hole. I guess that's what I'll have to go with. So I'll stick with this, the Cygnus X1, that is X-ray bursts. Accretion disk, X-ray bursts. Gamma ray bursts, the formation of a black hole. And then I kind of end with a fizzle, I feel like, because gamma rays, remember, are more energetic than X-rays. So also, gamma ray bursts can also be from not only black holes being formed, but also from supernova explosions and colliding neutron stars. So from left to right up here, you see in the gamma ray region of the spectrum kind of a burst of energy and its decay, kind of like we saw novas, supernovas and novas decay over time, kind of from left to right. Okay, so let's take a 10-minute break, come back about 10 till, and we'll go from there.